Hey, this is Stereo Police, back with yet another vid of a new addition to my collection, so to speak. My collection is ever rotating. I buy stuff, listen to it, work on it, fix it, and ultimately, usually, sell it, unless it's a keeper. And I'm wondering about this one. Will this one be a keeper? I was interested in it. Well, first of all, we're dealing with a Yamaha natural sound stereo amplifier. It's a integrated amp, model number A-1000. And so I'm just going to go over this real quick and show you what some of the features are. But the reason I was interested in this amp, by the way, I just unboxed it. Just came wrapped in all this crap right here. Just got it. It's an eBay purchase. And I was interested in this one because it is a Class A amplifier, and I wanted to, and I've read a lot online about the older model Yamaha Class A amps and how good they sound. And so I thought I'd give one a try myself. I've never had one like this before, and let's just go over some of the features here real quick and show you around, and then I'll take the cover off. We'll look inside, and then I'm going to do some tests on it. I'm going to fire it up, make sure there's no internal shorts, anything like that, and just run a couple quick tests to make sure everything is working as it should. Probably total harmonic distortion, and make sure there's no DC on the outputs, and things I want to do before I actually hook this up to my good speakers. I don't want to kill my Klipsch Forte 3s with something that's malfunctioning. So anyway, we have here, it's an integrated amp, and it's got this. Well, first of all, it might look plastic, but this faceplate is metal. This little drawer here is metal. I guess it's aluminum, anodized. So it's a super high quality look and feel to it. Looks very nice. I believe even this knob here is aluminum. It's not plastic. It doesn't. Yeah, it's a cold temperature, and so it's aluminum. And I think all the little controls down here, all the little knobs down here, yep, they're knurled aluminum as well. So are these. So again, super high quality. I have no idea how much this thing cost new, but it was probably fairly costly back in the day. And I like the look of it. It's very nice. So what we have is, of course, power, and I'm guessing this light will glow right here when the power's on. And here we have our switch to switch between Class AB mode and Class A mode. And I'm expecting when I fire this up and listen to it in Class A mode, I'm expecting these heat sinks back here to really produce a significant amount of heat, as it should, with the high bias currents involved in Class A. Okay, so I don't know what direct is yet, but I'm guessing that's just a preamp input. I'm almost certain of that. We have muting, and then there's all our selectors. 2 tapes, an auxiliary. What is DAD? I forgot. I don't know why I'm drawing a blank. Digital audio disc. Okay. Phono and tuner. And let's look behind the drawer here. I'm going to have to get down on my knee here to look at this. So what we have here is there's a headphone output. We have bass and treble with selectable cutoff points. So you can fine-tune the bass and treble with our cutoff points either in bass at 125 Hertz or 500 Hertz, and treble 8 kilohertz or 2.5 kilohertz. It's got one of those really cool loudness controls that Yamaha was known for, where it's not just a loudness button, it's a variable loudness. So right now it's on flat, but you can rotate that loudness dial and you'll get varying degrees of loudness, which of course loudness will accentuate the highs and the lows to compensate for how the human ear hears. And we have balance. We've got some subsonic filters. That would be mostly for a turntable. And there's a high filter. It's either off or it'll block frequencies above 10 kilohertz. Not sure what that would be used for. Yeah, I know the subsonic is for turntables. If you have your turntable near your speakers, you'll get feedback through the tone arm, so that'll block that subsonic blocks frequencies below about 15 hertz. There's our stereo mono switch. This is our record out, so I guess when you put a tape deck up, when you hook a tape deck up, you select what source you want to send to the tape deck. Normally that would be done by virtue of what you select up here, but I guess you can listen to one thing while you record something else, I suppose. And there's our phono, where we get some options here for impedances and capacitances. For a moving coil on the those left 1, 2, 3, 4 detents, and then on the right there's two settings for impedances I'm sorry, to the right the bottom two was for moving coil, and then for the left are your impedances for moving magnet impedances, as well as capacitances, to match as best you can your cartridge with the phono preamp that's built in. So it's pretty thorough. And speakers A and B. Let me rotate this around and we'll get a look at the back side. Alright, so back here we have our phono 1 and 2 inputs, our tuner, DAD, and auxiliary. All those are line level. And then there's our two hookups for tape decks. Our playback and record out for tape 1, and same for tape 2. And there's the speaker binding posts. Not exactly high quality, they kind of wobble around a lot. They're plastic. These are the least quality components on this thing. And you just stick your wire right down in there and pinch it up, tighten it up, and it looks like, nope, it does not, those are not capable of receiving bananas that I can tell. They're too small. And our voltage selector currently set to 120, and switched and unswitched power receptacles. And that's about it. Go ahead and remove the, looks like the top cover can be removed with total of 4 screws. So Alright, so here's the inside, pretty large heat sink. And haven't really studied the schematic. I pulled the service manual on this one. I got a pretty crappy copy of it, so it's hard to read and it's fuzzy and blurry, but haven't really had time to study it that much. But I did notice that it is a fully discrete circuit, no op amps in the signal path, and it's pretty much, the output transistors are bipolar junction transistors, BJTs. They're not MOSFETs. And here they are. And they're also arranged in a push-pull configuration, pretty standard power amp layout for the era, even for now. Everything in here is clean. Wherever this was sitting for umpteen years, it sure didn't get dusty in here. Usually dust settles through the upper cover, settles on everything. So This thing was kept pretty darn clean, unless somebody cleaned it, but I don't think so. It looks pretty original. Here is, I guess under this cover here is the power transformer, and the caps are under there. Can't really see them. Let me get a flashlight. They do these upper covers are looks like plastic pieces, and the actual caps are down there. They're green in color. You can kind of see them down there, maybe. No, actually, no. I'm wrong about that. These are the caps, and they are Yamaha. They must be original. I don't see any signs of anything leaking, and it looks good. Boy, everything's nice and clean. It's amazing. This was kept in such good condition. I don't see any signs of repair. No one's been in here butchering anything. So I think I got a pretty clean example of this amp. Pretty happy with it so far, but I don't know if it works. Yeah, I don't see any signs of anyone's been in here tinkering with anything, so I'm happy about that. And a couple fuses right there, and they are not blown. Alright, well, looks good, and I think what I'll do now is hook up a couple dummy loads and just turn it on to see if it actually turns on. Alright, so one of the, when you have a mystery piece of electronics where you don't know its history and you're not sure if there's an internal short, although there's certainly no signs of any damage in here. But just to be safe, especially if you're dealing with tube equipment or older, really old stuff, is you can either bring it up, you can either bring the power up slowly using a variac, or I have this little device where I'm taking the power cord from the amp, and I'm going to be plugging it into this little contraption. And I have one outlet labeled device, one outlet labeled lamp, and the lamp I have hooked up is an incandescent bulb. And the schematic of how this is arranged internally here it looks like that. So basically, I am plugging the amp into this receptacle here, and so the hot wire comes in, and then the neutral will come around, go through the lamp, and then out to neutral. So the lamp is in essence in series with the power going to the amplifier. And so if there is a dead short, the lamp will glow bright, but will limit the current flowing through the amp. So it's basically used as a current limiting device and as an indicator as to whether or not there's a dead short in there. So let's go ahead and plug this thing in. And let's see. And I have not that it's necessarily needed, but I have my 8-ohm dummy loads attached to speaker A. Okay, that was interesting. Alright, so here's what happened, and this does happen sometimes, is the lamp did glow. So I'm going to show you that. Now watch what happens. The lamp is glowing, but it's slowly dying out. So there is a bit of a glow, but it is, so that means this amp is taking quite a bit of current. I'm guessing maybe because that's in class A mode. Nope. It is glowing and lights are coming on. So there's not a dead short in there, and I didn't hear anything and I didn't smell anything. Sometimes the lamp will glow a little bit. It didn't glow brightly, so it's just there's not a dead short in there. So that's equivalent to bringing the power up kind of slowly. If the lamp was flat out bright and no lights were coming on, or I heard a sizzle or something, I know there's a problem. So I feel safe enough to go ahead and plug this into a main outlet. This thing is drawing a lot of current. There are some devices you hook up, the light doesn't glow at all. It's, you know, very little idling current, but this thing must be using quite a bit of current idling through that amp. I'm not even sure what's going on, but it's using quite a bit of current at startup. Maybe it's charging those capacitors. That could possibly be it. But I don't want to leave it in that state too long. It's probably charging the caps. But I'm confident there's not a dead short. Again, because we didn't glow super bright. I didn't hear anything sizzling or frying and didn't smell anything. So went ahead and turned it on. It's plugged into a regular outlet. Now I just heard a click. So that would be the relay, the speaker relays. Where are the speaker relays? I was looking for the actual relays. There's the speaker wires. They go over there somewhere, but this thing is hot and live now, so I'm not going to get near anything internally. I'm not going to touch anything. Just looking around. There's the speaker connection board down there, but I don't see any relays. Thought I heard the click coming from back in the back somewhere, but I must be wrong. It must be up front. Anyway, it's been running now. It's idling. Let me click it into Class A, so you can see that light comes on. The green light comes on. Looks like the power light is red. The Class A light is green, and there's a couple more lights. Direct is green and muting is red. Okay. I wonder why the power light is red. Normally you'd think that, you know, when you have the power on, you'd want to see something green. Red usually means danger, caution, something like that. So, no, I don't hear anything. I don't hear any snap, crackle, pop, and I don't smell anything. I wonder if the heat sink is, it's starting to heat up. Are we in Class A? You know, if it's idling in Class A mode, you would expect that heat sink to really start heating up. I'm going to leave it idling here for a little bit and see what happens. Okay, it's been about 3 or 4 minutes since I last cut, and I can tell you that these heat sinks they're getting pretty darn warm. Still not, they're not too warm to touch, but they're getting pretty hot. So, and we are in Class A, so it's idling at a pretty good lick there. By the way, if there was a dead short and the lamp glowed brightly, here's what you'd expect to see, something like that. And we didn't see that, so we saw it. I saw it when I first turned it on glow somewhat brightly, then it dimmed out, and that was capacitors charging and whatever idling current this thing needed. So, yeah, almost too hot to touch now. That's interesting. Well, I'd expect that with because we're in the Class A mode right now, so the quiescent current is really cruising along there, dissipating a lot of power. Okay, and by the way, according to the specs on this amp, you would expect that when in Class A, Yamaha claims that you will get a good clean 10 watts in Class A before it switches over to Class AB automatically. And I believe that's why they refer to it as auto Class A. It's not just going to crap out after 10 watts, it's going to transition into Class AB. And typically 10 watts is pretty hot. Is about all you really need, especially with fairly efficient speakers. I mean, when you're listening to music at a reasonable level, when you're really cranking it up like at, party levels, and you don't really need, Class AB is just fine. All right, and I'm making this video about, in my last video I talked a lot about Class A and Class B out of curiosity for my Yamaha AS1100. I'm definitely not obsessed by this. I'm curious. I'm curious how this is going to compare to the AS1100, because I mentioned this in the last video, but in terms of how an amplifier sounds, you can't judge the book by its cover. You can't judge an amp necessarily by what type of circuitry they're using. There's so many different variations and varieties of things that can be done from a design standpoint, and it really matters how it all comes together as a unified package in terms of the ultimate sound. And what really matters the most, of course, is how it sounds. And I've heard great sounding amps of all varieties, like that AS1100. That's a Circlotron. It's Class AB. And I mentioned before, and I'm going to do a video about this in the future, kind of on a tangent now, but I used to have a Lin amp, and I forget the exact, it's a Lin Magic, and I don't recall the exact model number, but I remember loving it, thinking it was fantastic. Ended up selling it to buy different stuff, just rotating gear. It's what I've been doing for decades. But I remember just really loving the sound of it, and the heart of that amp is an integrated circuit. It's a Thomson Microelectronics amp on a chip, so to speak. And the chip itself, if you were to buy it, it's a TDA. I couldn't remember it last time. I can't remember it this time. TDA 7293, something like that. The actual chip is about a $4 item. And they based their whole amp around it, and it sounded fantastic. Of course, they had their own power supply, and they built some circuitry around that chip, but the heart of it was that chip, and it sounded damn good. Okay, I'm on a tangent here. Let's go ahead and let's get a signal into this thing, and get a look at it on the scope, make sure everything looks good, measure the DC, check some THD, and then I'm done. I'll go ahead and hook it up to my main system and give it a listen. But I don't really like hooking anything up to my good speakers until I know that it's not going to damage them, and I also want to know that everything is functioning normally. Okay. Alright, so here's what I've got going. I've got my audio generator right there, and I am outputting, using the Keithley as a multimeter, outputting 1 volt RMS at a frequency of roughly 1 kilohertz. Doesn't have to be exact. Got 8 ohm dummy loads, and I'm feeding that signal into auxiliary. Go ahead and turn it on. There's click. Alright, so I think I'll measure for any DC across the outputs. Have to put the camera down for that. Let's see. Testing. Oh, nothing on the right channel. I mean, it's 0.003. Let's try the left channel. 0.005. So, absolutely no DC across the speaker load. So now it's time to fire up the scope, and let's see if we can get a look at what's coming out, and then maybe do some THD. Go ahead and I'm going to go ahead and hook up the scope. Be right back. Okay. So I'm scoping the right channel right now. Got the scope hooked up to the positive, and I'm going to chassis ground for the grounding lead of the probe. And there's our output signal. I'm gonna turn the volume knob right there, and you can see voltage RMS where it says cycle RMS right there, 1.4, 1.5. So it's a nice clean sine wave. Let's go ahead and let's find out. It's my calculator. Let's find out where this thing clips. Oh, by the way, we are in auto class A. Need to turn it down a little bit. Looking for that classic. Still haven't reached it yet. There's clipping right there. 31.6 volts RMS. What is that going to be? 30 watts? No, more than that. 31.6, 100 watts. 31.6 times 31.6 divided by 8 ohms. 124 watts into 8 ohms. Now, again, we are in Class A, and so somewhere, as I mentioned, after about 10 watts, it'll automatically switch over to Class AB, changes the bias. Feeling those heat sinks again. They were too hot to touch. So let's switch over to, let's turn off Auto Class A and see if we can exceed that 124 or 225 watts. About the same. So when it switches over to Class B, that takes over, and it's whether you're in Auto Class A or not, you're going to get 120 some watts per channel into 8 ohms. Powerful amplifier, no doubt. What would be interesting, what I think I'll do later, is to I don't want to try to get a tap on some of those output transistors. Take a differential measurement and find out. Let's get a look at that waveform as it switches over from Class A to Class B. I'm not going to do that today, but what I want to do now is, knowing that, let me do a frequency sweep. Make sure this thing's got full bandwidth. So go back over to the Keithley. We'll turn on frequency. And I'll just keep an eye on the scope. I know on the scope right there. Let's see what we're outputting 14 volts. What is that wattage wise? Hold on a second. Okay, we're running about 24 watts right now. So let's stick to that right there, and I'm going to start. Let's go down to, okay, we're at 10 hertz right now. And you know what? At 10 hertz, the amplitude has not changed. It's about as low as I can go on my audio generator. So let's go ahead and crank her up to about 100 hertz. Still at 14.8 volts. RMS. All right, let's go to the upper end of the ranges here. That's there's 100 kilohertz, 107 kilohertz right there. Look at that. Still got some level. Voltage is down to 8.9 volts RMS. So wow, let's get a look at that sine wave at 100K. Looks pretty good. So wow, this thing's got quite a bandwidth, even at 100K. I wonder where it really craps out. 48K. Well, guess what? A whole lot of nothing. Well, that's to be expected. I mean, not 48K. What am I right here? Hold on, I am 91K. I just hit a bad button right there. My apologies. 10K. Okay, my backtrack. 783K. There's a whole lot of nothing. Wasn't it 48K? 700K. Let's just back this down. Oh, look at this. See it starting to rise right there? I'm at 281 kilohertz. It's rising, and I'm at 120 kilohertz. Not that any of this really matters, but it's got quite a bandwidth. Quite a bandwidth. Okay, I think for the end of this video, I just want to check THD. Check that heatsink. Yeah, hot. Oh, and by the way, I was in auto class. I mean, I was out of auto class A. Let's go ahead and take her back into auto class A, and let's get a signal back down in some reasonable range. Hold on a second. Seem to be having, there we go, I was having some issues. Back down to about 1K. I was having some issues with my measurement there. It was looking a little funny on the Keithley. Okay, so back down into auto class A. I'm going to go ahead and hook the Keithley up to the output. Keithley hooked up to the right channel. I'm going to repeat some of this stuff for the left channel, but I'm just not going to show that because there's no need. Volume is down. I can tell you my resistors here are getting quite a workout because they're really starting to smell. I can smell them when they heat up. Okay, so we're going to shoot for clipping. I'm in auto class A. Watch for clipping. Now, right now I've got roughly 12 volts RMS on the output, and I've got 0.00A7 or something THD, which is that THD amounts to what's coming from my audio generator, so everything is fine with the amp. Let's go ahead and go for clipping. Okay, there's clipping. Watch the THD. Boom, it starts to rise. 12, 10. See, I don't want to take it up. So right up until clipping, we've got extremely low THD until you start hitting clipping. There's clipping right there. You can see it rising. Okay, so very low THD. Excellent. Very, very good. So at least I know the right channel is working extremely well. We'll give my resistors a break here. They're really heating up, and check the other channel. But everything is functioning normally. I could take THDs at different frequencies. Let's see, get a little signal going here. We go over to frequency, and let's go to roughly 20 hertz. Okay. There we go. So we're at 20 hertz. Okay, there we go. Got about 8.9 volts RMS. Okay, now let's go back to THD. The Keithley won't go below 20 hertz, but anyway, 0.09, which probably is what's the source of the THD, is probably the audio generator, but it's still pretty low. So let's go to a much higher frequency now. Okay, there's 19 kilohertz. Okay, 19K, close enough to 20. Let's do a little THD on that one. And 0.005, you know, it's low. Excellent. Very, very good. All right, so there's my overview of the what so far is a very nice unit here, the A-1000 Yamaha. I have no idea how it sounds. That's a whole different issue, but it's functioning normally. I'm going to go ahead and test the other channel, and I think I'll get her hooked up and give her a listen. But very, very nice so far. No issues. There's our 20K sine wave. And I've been testing the frequency response in auto class A, which is where I'm going to leave it. I mean, why would I not want class A for the first 10 watts? I can't imagine why I wouldn't want that. The only reason why someone might not want that is the heat produced. Now, if you have other components sitting on top of this, which is stupid to do, but if you did, you wouldn't want that kind of heat. I don't know. I'm leaving it in auto class A. But okay, well, anyway, enough for this video. Thanks for watching, and I'll give you an update on how this sounds, and it's particularly in comparison to my AS-1100. AS-1100, I just finished testing. Just finished testing it in my previous video. There it is. I haven't hooked it up to my system yet. I'm gonna compare these two. Anyway, enjoy. Ciao. Thanks for watching.